Hello everyone, so let's continue talking about the interpreter or the inspector, what the 010 editor names it as inspector. As you can see here, there are other values that we didn't check, like float. As you can see, this is 4 bytes, double will be 8 bytes, as you can see. So immediately once you click on half float, as you can see, float was 4 bytes, so half float will be 2 bytes. You can see string. This will highlight if there's any string. It's going to be like there was a string here, so it highlighted that. If we go, for example, let's say over here, and then you say string, it's going to highlight these, but these are really not strings, so it will be highlighting those that where your cursor is currently on. So let's just go back here, and again we click on this, then you can see it's getting highlighted. We can see also Unicode, so this is trying to read these bytes as Unicode, but since this is actually not Unicode, you can see we are getting gibberish or some value in another language. You can see also the DOS date and the DOS time. Those both of them are stored within 2 bytes. And if we go to file time, you can see that file time, which is used in most of the Windows system, we'll see those also later. They are stored in 8 bytes. So the granularity of and the precision of the timestamp when we are storing it in 2 bytes is definitely not going to be the same when we are storing it in 8 bytes. So here the precision will be much better compared to these 2 bytes. Okay, so you can see these are all the timestamps. You can see here this timestamp is 4 bytes, and it tries to interpret them. Like we go, for example, here, you can see it's gonna just highlight those are the 4 bytes that this is where this is coming from. But just because we are highlighting on 4 bytes does not mean that this is a timestamp. It depends on the file you are interpreting. So if this was a file and in its structure, it says that at offset 60, those 4 bytes represent a timestamp, and then you'll be able to come and interpret these values. Now, also, if you look, for example, over here, let's see this. So these are 4 bytes, assigned integer. We can also see, by the way, that this is represented in Little Endian. If you want it in Big Endian, then you just click on here and then switch. Big Endian, you can see the values are changing because when we read it in Little Endian or Big Endian, the values will be read differently. Or you can just go here and switch between them. So if you click on this, it's showing that now this is read as Big Endian, as you can see here in the lower right corner. Or if you click on it again, now it's in Little Endian. And as you can see, this is how the value will be excuse me, will be represented. Now it depends on why would I use Little Endian or Big Endian. It depends on the file structure and how it's represented. And you need to make sure, that you are reading those values correctly. So you can use this again to switch between Little Endian and Big Endian. And as you can see in the values or the output that we are reading, when we switch between Little Endian and Big Endian, the values are the data that we are reading is actually going to be different. Okay, so that's it for this video. Let's see you in the next one.